Visiting with Huell Howser is made possible through a generous grant from the Ralph M. Parsons Foundation.
We are standing in front of an honest-to-goodness Los Angeles icon, the world-renowned Griffith Observatory. I'm standing with Dr. Ed Krupp. Dr. Krupp, you're the director of this observatory. You're a personal friend. We stood here 5 years ago when the observatory was closing for renovations.
It's true. We're older. It's newer.
It's a lot newer. It has been closed literally now for 5 years. It is now opened back up, and a lot has gone on in those 5 years, hasn't it?
Major restoration and addition to the building to make it more pleasant for everybody.
Now, we're going to get a tour of the building on the inside, and that's where all the really exciting stuff has happened. But a lot has happened here on the outside as well. I've been up here at various times watching the work in progress. All of these beautiful big copper domes have been replaced.
Completely repaired, and the large dome over the Oschin planetarium has completely new copper on it. It almost looks as though it's been there a while, but in fact that was bright shiny copper for a little while during this operation.
It's got the patina back on it. Let's kind of set the stage historically as to when it was built and why it was built and what its history has been over the years.
Well, Griffith Observatory first opened to the public on the 14th of May, 1935, and then just continuously operated on behalf of public astronomy in Southern California up until the time we closed for this major job.
When this observatory was built back in 1935, was it a revolutionary idea? Was it a boosterism kind of a thing by the city fathers? Why here on the side of this mountain?
Griffith Observatory was kind of a revolutionary deal in 1935, but it wasn't revolutionary because it was an observatory. People were already putting observatories on the tops of major mountains here in Southern California for astronomical research. This, however, is a public observatory, and the booster was Colonel Griffith J. Griffith, who left the money for it in his will because he believed people should go eyeball to the universe.
So from the beginning, this observatory was for the people.
It was always intended to be the people's observatory, and that, in fact, is how it's operated.
Now, I've seen old pictures when they were building this thing. They put a lot of steel in it. This thing was built to last.
You know, we didn't have to do any seismic retrofitting of the building. It was being put under construction in the time of the Long Beach earthquake. That scared everybody. There were changes in design. They doubled the concrete pour, so this building, in fact, is solid.
So they built this thing to last and to withstand heavy earthquakes because it was being built right at the same time of the very strong and destructive Long Beach earthquake.
Very much part of the picture of its construction, but also that was a time when there was a belief in making it high-end for everybody. Fine materials were available, fine materials went into it, and that spirit has continued with the increased space that we've put here. Also, the same kind of classy materials that it always had.
They didn't spare any expense when they built this thing in 1935.
Well, I don't know about sparing expense, but what they did have was the money that Griffith left for it, and that did the job.
Before we tour inside the observatory, there is so much to see just outside here. This has obviously been cleaned up. I've never seen it looking better.
I haven't either. This is the Astronomers Monument, and you know those 6 great astronomers deserve a clean appearance on the grounds
now,
here.
What are we looking at? Because I can't remember exactly what this is all about. I know it's significant.
Well, we are commemorating here 6 of history's greatest astronomers to remind people of the kinds of achievement that astronomy has made over the centuries and how that's altered our perspective.
Copernicus.
We got Copernicus and, of course, Hipparchus from ancient Greece. But we're swinging around sort of in a funny way through time because we pick up William Herschel, who discovered the planet Uranus. That was the first planet discovered with a telescope. We keep on going. We get Newton, of course. He's responsible for gravity and even invented a kind of a telescope. But all of our modern understanding of physics comes from him. Then we got Kepler. Kepler developed the laws of the motions of the planets in the solar system from observations. And then, of course, Galileo. Galileo changed everything when he first pointed a telescope to the sky.
Who decided who these 6 were going to be? Was there a committee back in 1935?
Of course there was a committee.
There has to be a committee.
And, you know, prominent astronomers and other scientists all conferred and made these decisions. They really weren't bad decisions.
Now we're looking at this, this has always been here too.
This is the observatory's outdoor sundial, and mostly just to make the point that the sun moves every day and you can tell time from it. We've shifted its position a little bit, cleaned it up too, although we got a little more cleaning to do every time the birds come by.
Why did you shift its position from its original position?
It was bumped up very close to the Astronomers monument, and we just thought it would be easier and better for people to get all around it, and so we've just pulled it out a little bit.
Not only is this quintessential LA, it's quintessential Hollywood, because what a great place to come and look at the Hollywood sign.
This is the best place to see the Hollywood sign.
And this ties in to the history of this observatory as far as movie making is concerned. I know you've been asked this question a million times, but a lot of movies have been made right here.
No question. Over 300 major motion pictures have, in fact, included Griffith Observatory in the cast. We have been in enough movies to deserve a star on Hollywood Boulevard, but at the observatory, of course, the stars are the stars.
And why the observatory? What was its attraction for the movie makers? Why was Hollywood always been so interested in this building?
You know, first you got to look at the architecture and say, this is stunning architecture. It's interesting and strange. And then the setting. It's obviously the best piece of public observatory real estate in the world. And so motion picture producers love the scene.
Now, the most famous movie had to be the James Dean, Natalie Wood.
We love Rebel Without a Cause. That was the first movie that starred Griffith Observatory as Griffith Observatory, with even a planetarium show in it.
All right, now a lot has changed. Look at this view right over here. Even though it's kind of smoggy today, you really get a shot looking out at the city from all directions when you're standing up here, which is another one of the appeals to come up here, isn't it?
The place had a viewpoint at the very beginning. If you look at the old pictures, it's all cleared around here. Over the year, the scrub would grow, but part of the project was just returning the view. So you have this sense that you're out at the very tip of the world looking at the sky.
So you mean you cut some trees down?
We never touched the trees.
Well, no, but I mean, you opened up the...
all the scrub, all the scrub, yeah.
So you've got these big, broad vistas looking out.
This is a Southern California mountainside, and you need to have a look at the landscape.
I found something new here in the sidewalk. When you visit the Griffith Observatory these days and you look down at the sidewalk, this says Orbit of Pluto. What is this all about?
We have mapped the solar system right on the sidewalk. This is so people can really get a feel for just how big it is. We walk the orbits of these worlds from Pluto, across the orbit of Neptune, keep on going, and of course the next planet up a little ways is the planet Uranus.
So wait a minute, they're this far apart.
Yeah.
What's the scale here?
Well, the scale, of course, is matched to the Earth's orbit way up by the observatory, and you can see, in fact, how great these distances are compared to how small the Earth's orbit is around the sun when we get up there. We just keep passing the orbits of these worlds. Now Saturn, and then Jupiter, and see how they're getting closer and closer. We're hitting them faster and faster. Here's Mars, and now Earth,
Venus, Mercury, the Sun. Boy.
Now, if you have a big enough family, you can come on up here and put somebody out on every one of these orbits and get a look at what the solar system is really like.
It really puts it all in perspective, doesn't it?
That's exactly what it's there for.
What a view of downtown Los Angeles from up here. This, you know, there are not any bad views up here.
No, that's the whole point.
How was this thing sited originally? Who decided exactly where it was going to be placed?
Well, that was definitely a job for the engineers and the designers and the architects and everyone. Colonel Griffith originally wanted to put it right up on the top of Mount Hollywood. That was impractical. And so in the course of design, which came many years after his death, it was determined that this platform on the south slope was the right place.
And you know, from almost anywhere you are in the city, you can see this, so you don't really have to do a lot of advertisement. It kind of advertises itself, doesn't it?
The observatory's visibility is one of its greatest assets, and that, of course, was something that we had to protect. So in doing this whole job, we knew that the place had to look the same when we were done.
Yeah, because it does look the same. To me, I can't tell from the outside any real difference in the observatory. This is the old observatory we all grew to know and love over the years.
It's almost identical. There are a couple of things that you start noticing. Our camera obscura is a new instrument that just comes out of the roof now.
Now this is new, and it's called, and boy I love this because look at the juxtaposition again with the Hollywood sign. Everything ties into Hollywood. Camera obscura, what is that?
This provides a live panoramic image of the landscape around here. This optical instrument rotates around, and so you see the park and downtown Los Angeles and everything in real time in a dark chamber down below.
This moves, the top moves around.
Yeah, and that's where the optics are.
So the viewers would be down in the building looking at what they're seeing out of here.
It's like going inside a camera and looking through the hole in the shutter.
Isn't camera obscura an old thing, an old technology? Didn't that take place over 100, 150 years ago?
Easily. It was an old technique, even with just a pinhole, to project an image from the outdoor landscape into a darkened room. But with these optics, we can make an incredibly detailed image. And of course, the point of this is that this is an observatory on the ground where earth and sky meet. And so you go into the building and you're reminded that you make observations of your environment here.
And how much has the light pollution of the city obscured the sky here? Because we got a lot of lights out here at night.
No question Los Angeles pours light into the night sky. But actually, over the last several years, the Bureau of Street Lighting has made improvements in the kind of lights they put out there. And so you see areas in the city that have actually gone dark because of this kind of illumination. Now, this is still not a great place for research astronomy, but it is, in fact, a great place for public astronomy and a great place, in fact, to see the lights of LA.
Public astronomy, and that's where we are right here, because this is the telescope in here that is open to the public.
We are open every clear night that the building is open, just so people can put their eye against that eyepiece and see what's up in the sky that night, with a live telescope demonstrator to operate the instrument and tell people what they're looking at.
Let's go inside. Here it says, telescope entrance, admission free.
That's right. In fact, the observatory is free.
It always has been.
Always has been.
Always will be.
Always will be. The only thing we charge for is, of course, the planetarium show in the Samuel Oschin Planetarium. And during this period of surge in attendance, we've got a timed entry reservation system. You must make a reservation and take a shuttle from remote parking. That's just so you can get here at all and we don't have traffic congestion.
All right, let's go in the telescope, and the admission is free. We're coming inside the telescope. Now, I don't know, in the scheme of things, is this considered a big telescope, a small telescope? What is this?
This is not a big telescope as far as research is concerned. It's a pretty big telescope for the average person to have a chance to look through. In fact, more people have looked through this telescope than any telescope on Earth. It is the perfect telescope for Griffith Observatory. It looks like a telescope, it works like a telescope, and we get to put people eyeball to the universe every clear night.
More people have looked through this telescope than any telescope on Earth?
That's true, and that's what Colonel Griffith intended his telescope to do, and it's done it.
I'm embarrassed to say I've lived in LA 25 years. I've never known about this telescope. What happens? Do people just come in? Let's walk up the stairs here. And whoa, it moves. Do people come up here and look in the telescope from up on the steps?
It depends on where the telescope is pointing. We've got it low on the horizon right now. We're doing some testing of the equipment in the daytime. Actually have it pointed out at Mount Wilson in the solar telescope over there. But this telescope will shift its position depending on where the object that you want to target may be located. The stairway is intended to help people get up to wherever the eyepiece might be.
Yeah, boy, this is amazing. And are the lines long? I mean, everybody wants to look through something this powerful. I imagine you really get a close-up view of the planets.
You see the moon and the craters and mountains on it. You can see close-ups of the planets. In fact, Saturn is the best of all. Seeing somebody see Saturn through this telescope for the first time is about as good a kick as there is.
Now, was the telescope restored or renewed in any way, or was it perfect from the beginning?
It was in pretty good shape. We've cleaned it up a bit. We've added some refinements, some additional technology that's been put on it, but we've also completely rewired the dome. So all the electrical service up here is new, as well as the furniture and the things to help make the telescope work.
A new, improved, cleaned up, ready to go telescope.
Ready and rolling.
Okay, we've come down off the roof deck up where the telescope is, and we're standing in front. I love this work here. What kind of architecture is this? I've never really figured it out.
You know, it's a mix. It's got an official name. It is Greek Revival, Beaux-Arts, 30s Moderne.
Wait a minute. I bet you can't say that again. What is it?
Greek Revival, Beaux-Arts, 30s Moderne.
So was it always meant to be this kind of a hodgepodge? It's a beautiful looking building.
You know, the architects were looking to various themes that they thought were appropriate for the purpose of the building and the location. And this classic revival sensibility was very much a part of the 30s, as was the sensibility of the 30s, too. So there's a little streamline, a little bit of this and a little of that. The domes make it very 30s.
Isn't it amazing and wonderful that over the years, nothing was taken away to modernize it? Because a lot of buildings were damaged over the years when they wanted to kind of spruce them up to make them modern.
You know, I think this building protects itself. You know, it has such an identity, such character, that everybody who's had something to do with it, you know, kind of merges with the architecture and tries to take care of it.
Another change in the Griffith Observatory, I was going in the old entrance that I've been used to using all these years. We can still go in that entrance, but you're directing us over here to a new entrance. How many entrances are there now?
You know, there are 7 entrances to the building. It is far more accessible. We know that people disperse all over the grounds when they get here, and this entrance is featuring all of the new architecture and, in fact, a major new astronomical instrument that is incorporated into the architecture. Nothing like it on Earth.
Boy, I tell you, there are no bad views of the observatory, are there?
Now, you got to give the architects credit.
Well, we've spent time outside. It's now time to go down these stairs and go inside the observatory. And coming down these steps, now this is obscure and wonderful because this has Dr. Krupp's handprint all over it. You have not left any stone unturned in the design of this building.
Or any star allowed to move without our keeping track of it.
What is this?
We are descending into the Gottlieb transit corridor, and these stairs are angled straight up toward the north pole of the sky, the North Star. This banister is also pointing up there. If you get down at the bottom end and look up, you'll see the North Star there. The whole sky turns around that north pole of the sky, and so the sky also moves across this line every moment. This line in bronze on the floor is like the Greenwich Meridian. This is the Griffith Meridian, the north-south line.
So you're telling me that if we stand down here during the night and just follow this rail up, we're going to be looking directly at the North Star?
Bang on.
When do you think up these ideas? When do you come up with the idea of having the railing put in a certain position so when you stand at a certain position you can see a certain star? This is obscure.
You know, you look at the architecture and you seek opportunity, and this was an astronomical opportunity.
So that's the idea, is that when people come here, they really have to open themselves up for the possibilities of learning obscure things and wonderful things at every turn in their visit to the observatory.
The whole idea is to make people more at home in the universe. Turning them into observers, visitors into observers, is what it's all about.
We're inside the...
This is the edge of space overlooking the new Guenther depths of space. This is the underground expansion of Griffith Observatory.
None of this was here before.
It was rock. The front of the building, the old north face of the building, is just that away, and we are where there was once lawn and then rock.
So this was all dug out?
All dug out, all excavated to create this new space.
Okay, we're on the edge of space in this new space, which means California meteorites, and you've got one, is that that's a little meteorite in there.
It's a real meteorite embedded on the ground of a dry lake bed. That's why it's visible. In fact, you can even see pieces of the dry lake bed with it. That is one way to find meteorites, these pieces of the universe that come to Earth and allow us to get our hands on them.
Now, this isn't a meteorite.
Not a meteorite, it's a shatter cone, which shows that meteorites struck the Earth. You know, there was a time a few hundred years ago, people weren't even sure rocks from space could hit the Earth. But this is part of the evidence of how an impact changes the rock that it strikes.
That's out of a shatter cone caused by a big meteorite. And look at this lady down here.
Yeah, that's Mrs. Hodges in Sylacauga, Alabama, one of the few people known to have been hit by a falling meteorite. She was hospitalized, obviously quite a bruise.
So that big bruise on her thigh is from a meteorite falling.
It's exactly where it is.
What are the odds of being hit by a meteorite falling?
Pretty slim, pretty slim. And she thought that because it hit her, it ought to be her meteorite. The owner of the house she was renting thought it should be his meteorite. They called in the University of Alabama. That's where the meteorite is today.
Okay, now we're looking. Now this is what I think of when I think of a meteorite. This is a meteorite.
This is an iron meteorite. It comes from Arizona, one of our big meteorites on display here at the observatory. And this is a meteorite you can touch.
See, people love to touch them, don't they?
And when you touch this, you're touching outer space.
Yeah.
That's the whole point of the edge of space. This showcases the things from space we can actually get our hands on. Most of astronomy is remote viewing with telescopes, but some things come to Earth. We even bring things like moon rocks to the Earth, and there is, in fact, a moon rock on display at Griffith Observatory, too.
How far out did this come from to land on Earth?
The original source of this was somewhere between the planets Mars and Jupiter, certainly hundreds of millions of miles away.
So it was huge and burned up to this.
Well, it was probably bigger than this, and this is just a fragment of something much larger.
Yeah.
This was part of the much larger mass that caused what they called Meteor Crater in Arizona.
Well, you got part of it here.
Right here.
And from the edge of this was the edge of space.
This is the edge of space, this mezzanine.
And this is, we're going to go down and look at this in a minute. This is an amazing place right here, but you wanted to bring us over here to look through these little telescopes.
You're looking at the Guenther depths of space, the new underground expansion, and the north wall, 150 feet long, 20 feet high, is the biggest astronomical picture in the world.
So all this black wall with the stars and the universe and everything on it back here, that's the largest
astronomical picture in the world.
And that's an actual photograph that you've blown up, put on the wall, and then people stand here and look through the telescope.
We've got telescopes underground so you can make your own observations. The Caltech team on Palomar Mountain obtained that information that makes up that picture.
Oh my gosh, you can really see a lot through here.
There are nearly 2 million objects on that wall, and yet it's only 1,000th of the sky. I can cover up with my finger the amount of sky in that wall. And remember, there's the whole rest of the sky. It is incredible, and that's the job of that picture. The big picture is telling people just how extraordinarily huge it is.
It's to overwhelm you, and I can see this once the observatory is open. This is going to be a very popular place for people to come and look, because at first glance, looking at that wall, I wouldn't get that excited about it until I knew what it was and how it comes to life through these little telescopes.
And you can walk right up to it and see the kind of thing that an astronomer sees when he or she is doing research.
We are leaving the edge of space and going into the
Guenther depths of space.
The depths of space, and look at this. What are we looking at? You've got all the planets lined up here.
Well, we've got the worlds of the solar system all scaled, and at the far end of the room there's a big drum. That's the Leonard Nimoy Event Horizon Theater. If that drum's diameter is the sun, then all of these worlds are scaled to each other to the right size, and here's Pluto.
Wait a minute. Pluto is that little compared to, what's that right next to
You got Neptune right beyond it.
So Pluto's just a little planet.
It was the smallest planet in the solar system. And of course, that small size is what caused astronomers to reclassify it.
But you left it up there.
You know, doesn't matter what they do at meetings, Pluto is always welcome at Griffith Observatory.
You just made a political statement there, Dr. Krupp. Oh boy, look at this. We're heading down into this. Now this is a beautiful big room. And obviously this room, the whole room, pays homage to the planets.
Well, it's the planets, but not the planets that we used to think of as just worlds. This room is about the transformation of perspective. And one of our perspectives that's new is that planets, worlds in space, aren't just worlds anymore. They're landscapes. We have gone to these places, and we even give the rocks names on places like Mars. And so our emphasis is, what is it like to be there?
Boy, look at this. This is, obviously, these are the rings of Saturn here. These are really, I mean, this really gives you an idea of how magnificent this planet is.
The whole point of this place is, in fact, to have what you can't get at home. It's not a book. It's not a website. It's monumental in scale, and you have to come here to see it.
Now, are each of these exhibits, there are a lot of them are interactive, so you can actually, if you want to stand in front of the Mars exhibit, you can get as deep into this as you want to.
Every one of them has a story. Every one of them has a scale. You can weigh yourself on every world. My advice is, in fact, don't go near Jupiter.
Because you're going to weigh a lot over there, aren't you? Look at this. What is this?
Well, here we are. Here is the home planet, Earth, and so our area for the Earth includes the observatory seismograph. The whole place is about instruments, and this is one of our instruments.
Is this still operating?
It still operates, detects earthquakes just like it always did. An earthquake around the world will show up on the drum with the ink pen going back and forth because of the vibration.
And here's Earth.
Large planet.
Given it its own place over here.
Yep, and we also have a projection model of the Earth that allows us to show people things like the atmosphere, continental drift, everything.
And look at this. What is this?
You know, this is the Zeiss Mark IV planetarium projector, the planetarium projector, star projector that used to be in the old planetarium here at Griffith Observatory.
I'm so glad you saved it, because how many hundreds of thousands of people sat and looked at the star show through this?
No question it's an historic artifact, but it's not here to preserve the memory of planetarium technology. This is really about the way in which we have modeled the universe, and we use something like this projected on a dome to give ourselves a sense of what the universe is like. And of course, in the new Samuel Oschin planetarium upstairs, the technology is completely transformed.
We're going to see the new one in just a minute, but this is the old one that was here from 1964 to 2002, and I got to tell you, just looking at it, it looks older than 1964.
When we were closed, it was sparking, and we had to use street lights in order to make the stars shine. You couldn't get parts, you couldn't get service.
And here's the wall, the snapshot of space that we were looking at through the telescopes over there. Can you touch this?
Sure.
Is it okay?
Yeah. This is porcelain enamel on steel, 114 panels.
So you want people, well I
we
don't encourage people to touch it, but it's right here so you can see it.
It is made to last. And when you look at this, you're looking through an incredible depth of space. You're not only looking at the stars in our own Milky Way galaxy, but you see distant galaxies beyond, and these very faint and fuzzy objects are even more distant galaxies.
So wait a minute, this is a galaxy
with hundreds of millions of stars in it.
This is a galaxy
that is
with hundreds of millions of stars. Yeah. This is a galaxy. This is a big galaxy.
Bigger, and even larger ones over.
Look at the size of this galaxy here. So this must have billions of stars in it.
It does. And these galaxies all belong to what's called the Virgo cluster. Now, most people don't know that the Virgo cluster is part of the neighborhood. It's the huge metropolis of galaxies that's closest to us. We're way out in the suburbs from this cluster, but this cluster dominates our neighborhood of space, and so that's why it's here on the big picture.
So this really just overwhelms you if you realize that you're looking at hundreds of trillions of billions of stars.
You're right
I
on
guess
the...
there isn't even a number you can put on it, is
We
there?
do know that there are 2 million objects on the big picture, and 1 million of them are galaxies.
But that's just on this picture
Just on-
right here, which is what you see.
If I cover up the sky with my finger, this much sky is what's in the big picture, and that's all. Only 1,000th of the whole sky.
Now, isn't that what we've got Einstein doing over here?
Einstein is making that message clear. He's over here sitting on a bench making the same gesture. He's trying to make the point that that big picture, which is extraordinary in its richness and its size, is really just the tiniest piece of sky. And if there's that much in just that tiny sliver of sky, then think about how much there is in the whole universe.
Did you put all of this together, this idea of Einstein with looking and seeing? And
We've got a whole team that's worked at Griffith Observatory to pull these ideas together.
Because I've never seen Einstein portrayed like this with his finger up.
You never have. This is unique to Griffith Observatory.
Are people encouraged to sit
Sure,
here? Can
yeah.
we sit next to him?
Yeah, we can not only sit next to Einstein, we can do what he does, which is make the point that the big picture is a huge picture but a small piece of sky.
Wow. Now we're back in familiar territory, the original main lobby. And this has all been here since 1935, but it looks better than I've ever seen it before.
It is better than you've seen it before, unless you were here in 1935.
What are we looking at here? I've forgotten what exactly this is.
This is the Foucault pendulum, and it demonstrates that the Earth is rotating, spinning on its axis, which causes day and night. That is not something you can feel just by walking around on the ground, but this pendulum swivels as the time progresses, and so you can tell that the Earth is turning under it. We have pegs that this thing knocks down, and of course everybody cheers when the pegs go down.
And this has been going back and forth since 1935.
Yeah, except for this short period of time when this room was a construction site, because we had to restore everything in there, from the floor to the ceiling, the spectacular Hugo Ballin murals.
Yeah, let's talk about the ceiling, because we're surrounded by these original pieces of, I guess you'd call them murals or artwork. I'm not sure what they are, but
They are really unique to Griffith Observatory, murals painted by Hugo Ballin. It starts with the canopy, the top of the sky, which is all the mythology of the sky. And then as you start coming down along these walls, you hit the sciences and the panels that are on the walls, and gradually the axis of this pendulum and the turning Earth brings you right down to ground floor.
how hard was it to restore these things? Because they look brand new.
It was a lot of work. We had to fill this room with scaffolding so that the restoration experts could be up close to them, and it was done with distilled water and cotton swabs.
Do you think most people, because I'm always so excited when I come in, really ever stop to take the time to appreciate this artwork?
People don't necessarily recognize what a treasure of art this is, but we help the process along because, again, Griffith Observatory is not just astronomy. It's astronomy and people, and our guide staff is positioned throughout the building to give talks constantly, and so one of the talks we give in here is about the murals.
Okay, now we've got exhibits down here, we've got exhibits down here, and we've got the main planetarium, everybody's favorite.
Samuel Oschin Planetarium just through the South Gallery.
Okay, now this again we're on familiar territory right here. This is the way that you always came into the planetarium right here. And you've kept, I love these doors, the original, what are these?
Well, it's a combination of bronze and leather and other metals as well, and these, of course, are historic doors, and they, like everything else of historic fabric in the observatory, have been completely restored to their original grandeur.
Now, it's almost impossible to convey what it feels like inside this planetarium. You have to be here to experience it. Anybody watching who's been in here over the years understands what I'm talking about. This has always been one of the high points of the observatory experience, hasn't it?
You know, it's an immersive experience, and that's why you really can't duplicate it. It's not something you can get at home, and it's a combination of technology, live speaker, and then the emotion. It's not just information, but it is, in fact, the emotional content as well that's important.
Our camera can't pick it up very well, but we're in this domed room, and you can't see any seams on the ceiling, so it looks like when you're sitting here that you're really looking out into the universe.
The goal with the architecture and interior, the Samuel Oschin Planetarium, was to create that cathedral vaulting effect so that you would have no idea where that roof over your head is, that it was an infinite sky, pristine and remote and luminous, and of course we've succeeded.
And we're looking at the new, we saw the old one downstairs on exhibit. This is the new one here.
It's a Zeiss Mark IX Universarium fiber optic star projector.
Oh my gosh.
It produces the most accurate, the most awe-inspiring, the most gorgeous dome full of stars in the world.
Now this show goes on about once every hour?
There's a show presented just about every hour throughout the day, all of our normal operating hours.
And for anybody who remembers the old planetarium, the big addition, let's go right over here and have a seat, because the new addition that people are going to love are these amazing chairs that you sit back on and look up at the sky.
You know, the old planetarium seats violated the Geneva Convention. They were officially cited as the most uncomfortable seats in the Milky Way galaxy. But our goal here has also been to improve the visitor experience. So there are only 300 instead of 600 seats in this theater to make it more pleasant for everybody.
This is one of the high points of a visit to the Griffith Observatory. Coming in here, sitting back in these seats, looking up at the sky and hearing the live presentation, which really is very poignant and very thought-provoking, isn't it? It was made to be that way.
We want people to have a chance to reflect for a moment, not just on the universe, but their place in it.
Now we're going to get to see something, well, we saw part of it up on the roof, but here's the part down here, camera obscura. We get to see how it actually...
There's the rest of the instrument.
Oh my gosh, look at this. What is it doing? It's just projecting it on this round white tabletop here?
We're in the camera obscura. We're getting a live panoramic image of Los Angeles. We're just passing by downtown. Of course, the scene changes constantly with the lighting changing as the sun gradually moves through the day.
So now we're looking on the picture just flipped.
Yeah, we've swung around to the western horizon from the perspective of the observatory and gradually moving up the hillside slopes into Griffith Park.
Boy, there comes the Hollywood sign right here. Boy, I predict that this is going to be one of your most popular exhibits in here, don't you think?
I think so, but the trick here is to remind people that they're looking at a live image being produced right now, live in here, rather than some kind of a film or anything. And this, of course, is another instrument in a building that's filled with instruments.
So we are looking, because we were up on the roof up there and saw it on the upper deck, we're looking at that camera turning around. There's the monument out in front that's a little out of focus, I guess, because it's so close.
That's right.
And we're just looking out at a live picture panning around in a 360 of what's going on outside of the Griffith Observatory at this moment.
When people come into the observatory, we want to remind them it's an observatory. It's a place for looking at the sky and connecting that to the landscape. And so part of the job of this camera obscura is to remind people, wait a minute, you're inside a building, but we're looking at the universe.
I'm not sure what I'm looking at. Radio, microwave, infrared, visible, ultraviolet, X-ray, gamma ray.
We are here in the Hall of the Eye, but the last chapter in the story of the eye is what the eye doesn't see, what's beyond the visible. We have the same part of the sky on each of these disks as you would see when you look at the center of the Milky Way. But this is what it looks like in each of these different kinds of energy. And we've even got an infrared camera on us so that we can see what infrared energy is.
We're on infrared right now. There's the There I am, right there. Look at this.
We are glowing in infrared.
Wow, kids are going to love this. And again, it's a little overwhelming because you're seeing things that you maybe not have consciously thought about before.
It just takes a minute, though. Every one of these waysides, every caption is condensed down to just the essential information. And between that and between our guide staff, it isn't hard to pick up what these stories are all about.
How long do you think the average person could spend in the observatory going through it and really getting from it what it has to offer?
We know that a person can easily spend 3 hours here and not exhaust the place, but still, in fact, have a great time. Take in a show in the Oschin planetarium, see the film in the Leonard Nimoy Event Horizon, see all the exhibits, maybe look through a telescope at night.
So 3 hours, but then they need to come back and see it again.
Sure. And you might decide just to make a short trip and, visit the whole grounds and take in the view.
This is a television first. I am now speaking to you on the new infrared television screen in the new Griffith Observatory. Everything is infrared. Over and out. Beam me up, Scotty. Now this takes us back, way back in time.
Before you ever start thinking about all the colors our eyes don't see, the first thing you have to do is point a telescope at the sky. Galileo was the first person to do that and make interesting observations. That's why he's on the Astronomers monument out front. This is the best replica of Galileo's telescope that exists. I went and photographed it in Florence, and then our model maker actually went in person, examined the telescope, and constructed this in exact detail. This is a working telescope, just as Galileo put his together. Even on the inside, it's the way it originally was.
So this is really what, I don't want to say what started it all, because people had been looking at the heavens forever, wondering what was up there and what it was all about. But this is what really got it all started right here.
You made the point exactly. This room begins on the other side with what our eyes get from the sky and how people for thousands of years just looked with their own eyes, what they could do with the sky. But Galileo points a telescope at the sky and everything changes.
Day and night. There's so many of these exhibits. I'm not sure I know. There's so many of them. How do you get a handle on them?
Well, first you got to go and you look at them all. There are more than 60 new exhibits. This is the first time since 1935 we've had a chance to create a comprehensive, integrated, unified exhibit program once again. The focus is on astronomy and turning the visitor into an observer. And in this area, in these alcoves in the Amundsen Hall of the Sky, we concentrate on the basic interactions of the sky from platform Earth. Earth, sun, and moon. And it produces some of the most fundamental experiences we have, like day and night.
All the clocks are going to let you know what time it is in different parts of the world, what's day, what's night. You have lots of things that are spinning, moving, lots of colors, sound. You're making these things, they kind of come out and grab you.
We want models to help people get a direct sense of what's actually going on, both mechanically in the solar system and then what the effects are. What you can see if you spend a little time with this is how the amount of sunshine we receive in Los Angeles changes throughout the year. It's coordinated on the globe with the view up on the back panel that's a Southern California scene. And then, of course, as you said, we've got the clocks for the rest of the world.
We're going to get excited at these exhibits, but Dr. Krupp gets excited at these exhibits too, like this one, Dr. Krupp. There are lots of buttons to push and lights that go off.
This is a display of all the chemical elements, and it's not just for chemistry. This is to show how we're connected to the universe. If I press this button, I get the elements that were produced in the Big Bang 13.7 billion years ago. Stars, just as a matter of course, produce all of these elements through their thermonuclear reactions. And when a star explodes in a supernova, it produces these elements. These are the elements in us, in our bodies, and the elements in us come from the stars, and that's the point of this exhibit.
Wow! So you've got, let's do the Big Bang again.
Elements in the Big Bang: hydrogen, helium, and lithium.
So just three.
Just three. And then, once stars get into working on this, which takes billions of years before they're even formed, but when they start manufacturing elements, you get many of the lighter elements. The heavy elements, those are produced by supernova explosions. And we have a video as well that explains what a supernova is, how it works. And then these are the elements in us.
In us. So it makes the connection between us and the stars.
Right on the money.
I'm pushing the button for helium and for krypton. Now, what does that have to do with kryptonite, i.e. Superman?
You know, if this were kryptonite, Superman would be in trouble. As near as we can tell, there's no such thing as kryptonite, but I'm sure that that word was made up from this gas, krypton, which is one of the inert gases. This doesn't interact with anything. Chemically, it just is a quiet little gas that just sits there in the tube.
But it sounds a lot like kryptonite, and that's got to catch people's attention when they come in here and see this.
No question about it. Part of the reason we have to select the elements we have here is to catch people's attention.
Now that brings to mind, this planetarium opened up, this observatory opened up in 1935. Back then, a lot of things that people thought of as science fiction have since come true.
No question about it. In fact, it's right in the very fabric of Griffith Observatory. The first director, Dr. Alter, who was a specialist on the moon, he did research on the moon, and he also invented the traveling planetarium show, that is, travel to the moon. He took audiences there and set them down on the moon. And he predicted, he said, you know, in the decades to come, we will, in fact, land people on the moon. And, of course, that came to pass.
So how futuristic have these observatories, has the Griffith Observatory always been? Has it always been something kind of on the edge?
I think it's always been on the edge. That's where it's supposed to be. This is, of course, the cutting edge of science. And that's what the audience comes here and expects to find. What are the discoveries that are being made out at the observatories and the other laboratories?
Okay, the former director predicted we'd land on the moon. What are you predicting right now? We're going to put this in a time capsule and open it up 50 years from now.
No question. We're going back to the moon, we're going to Mars, and then it's nothing but infinity and beyond.
You're putting that on the record.
No question.
Now, here's an exhibit of the sun. So obviously the sun is up here, and what is all this?
We are making the point that the sun that we see every day is really just a star, like all of the other millions of stars in the sky, millions and billions of stars. The sun is actually nothing like the largest star or even the smallest star. It's right there, sort of in the middle of this
Wait a
line.
minute, this is our sun right here?
That represents the size and the brightness and the temperature of our sun.
What is this and what is this?
This is a giant star, Arcturus, and a supergiant, a red supergiant star. In fact, that's even not big enough. To do that right, it'd fill this room.
So they're stars, supergiants, that are that much bigger than our little sun down here?
Just like there are huge planets that dwarf little baby Pluto.
See, I don't think most people know. I think most people think the sun is big.
The sun is big compared to the Earth, but when it comes to other stars or the universe as a whole, the sun is but a speck as well.
And here, we're looking at the sun.
This is a live image of the sun produced by Griffith Observatory's solar telescope up in the dome, but this is where people see it. And in fact, more people have seen the magnified image of the sun here at Griffith Observatory than anywhere else on Earth.
So this is the sun right now.
Well, it's really the sun 8 minutes ago, because it took the light from the sun 8 minutes to travel the 93 million miles to get here. So that was the sun just a short time ago, but for all practical purposes, it's right now.
Now, when there's an eclipse, can people come here to see it here?
An eclipse, if it's visible in Los Angeles, it'll be visible right on this screen. But now, with all of the new technology we've got in the new spaces, we can bring, with the telescope, that eclipse into the Leonard Nimoy Event Horizon, into the Samuel Oschin Planetarium, and in fact, into screens all throughout the building, so many people get to see it at once.
So this place is going to once again be very popular when events like that take place, eclipses.
No question that we have planned for future astronomical events. If you're going to observe them, you've got to be at an observatory.
We're back outside, and I missed this the first time around. Has this always been here? Have you moved it? What?
The Rebel Without a Cause monument with James Dean has been at Griffith Observatory for a long time, but it has just come back out from under wraps and moved to this new terrace location.
Now, it was put here just because of the movie and the prominence he brought to the place, or because so many tourists ask about it? What's the deal?
Well, you know, Griffith Observatory has been in the movies since before the observatory opened. It was in movies with Gene Autry in The Phantom Empire before the dedication of this place. We've been in so many movies that we figure we deserve a star on the boulevard. But Rebel Without a Cause with James Dean was the first film that treated Griffith Observatory as Griffith Observatory. The building got to star as itself, so we love that film.
Wow, now I would imagine that many of your visitors from all over the world want to see this and make the connection with this.
There is a connection with Hollywood, of course, in Griffith Observatory. We overlook Hollywood after all, but at Griffith Observatory we always remind people this is where the stars are the stars.
The real stars.
The real stars are here.
All right, let's walk back around here, because here it is, the beautiful, old, new Griffith Observatory, and there's some new rules at the observatory, and this is really important for people to listen to and understand, because they're going to be disappointed if they don't.
Absolutely the case. There's only 199 parking spots on the hilltop here, and we know that the surge of people wanting to come here is just going to overwhelm us. And so for that reason, for a temporary period, just to be determined by how long it takes us to work through it, it's by timed reservation only. By reservation only at www.griffithobservatory.org. You get a timed entry, and you have to take a shuttle from remote parking site to get here, but that is intended to make the visit more pleasant so you're not caught in traffic.
So if they go to the website or the phone number that we're putting up on the screen, you need to get this is like what happened at the Getty when it first opened. It's got to be a rush of people wanting to come up here, because it's been over 5 years since they visited this place.
We know that people, in fact, want to descend on Griffith Observatory, want to return, and we want them to do that. But remember, one of our key principles was improving the visitor experience. And if we backlog the traffic and do gridlock throughout this neighborhood area, we won't be serving the people who want to get to the observatory.
Well, I got to congratulate you. You did an absolutely wonderful job, because the old place has maintained its charm and its history and the things that we remember so well about it. And at the same time, you have expanded it greatly, added all these wonderful new state-of-the-art exhibits. It's really the best of both worlds, isn't it?
Thanks, Huell. I hope that's what we've done. If so, it's just like the universe, ever new, but always what it was.
Thank you very much. Let's just stand back and get a shot of it right here. The Griffith Observatory. It's back after having been closed for 5 years of restoration and renovation and upgrading. It's an absolutely iconic place here in Los Angeles. Been here since 1935 and is today alive and well and back to opening up the heavens for all of us to enjoy. What are you predicting right now? We're going to put this in a time capsule and open it up 50 years from now.
No question. We're going back to the moon, we're going to Mars, and then it's nothing but infinity and beyond.
Visiting with Huell Howser is made possible through a generous grant from the Ralph M. Parsons Foundation.